And starting with the very first question, right? So we can just go for an overview of what are some of the key technological advancements that's driving the evolution of the small satellite infrastructure and ground systems, and how will these advancements change the future of the industry. So basically covering what's happening, the innovation in the small sat infrastructure and the ground systems. And then we can talk about how this shapes the future. So maybe we can start with Srinath first, and we can go ahead and get a comment from everyone else. So
pleasure. Thanks for that. And actually, it's a very interesting topic, and it's the topic that we should focus on because, the launch segment has innovated, the satellites have been innovating, but the small sat infrastructure and ground segment is all kind of in a catch-up game, especially ground segment is in a catch-up game. I work for Telespazio. We focus on ground segment, and we are currently establishing a new division called eSlice, which is focused on providing service to new space constellations. So with respect to ground segment catch-up game, I think we can look into different sets of parameters. One is currently we are using S-band for communications, and then we are also exploiting the laser terminals that are trying to be done from ground to space, but still a lot of development is pending on the manufacturing side of things. But also, as we saw from last presentation from Planet, there's a lot of automation and software that is kicking in to take care of the innovations in the interim when the product is still under development. So most of the processes are automated, most of the ground segment is automated. So there is a lot of innovations happening on the back end to catch up with the growing number of satellites up in the sky. Thank you.
Perfect. So Olivier, would you like to add on that?
Yeah, sure. I'll focus on one point that Srin just mentioned about the communication, especially laser communication, which is Skylab's focus. So laser communications is extremely useful for a number of new use cases that are enabled by new space, small satellites, Earth observation, communication, and sovereign communication are three examples. So there are three major promises that laser communications bring compared to RF. These promises are super high data rates. 10 gigabits per second is kind of the bare minimum. We're already talking about 100 gig for the near future. The second one is no spectrum, no license. And the third one is low probability of detection and interception. At Skylabs, we deliver the first promise, enabling super high data rates from space to ground, which is one of the challenges that has been tackled in the past few years. The first laser links that we see are intersatellite. They're powering new constellations. There's still a lot to do on the ground. This is what we are tackling at Skylabs.
Perfect, wonderful. So Juan, I would like to move to you now. So being again ground station operator, so I would love to hear your points regarding what's happening in the ground segment. What innovations are there that are enabling the advancement of the market?
Perfect. Yes, from our perspective, we identify the main improvement that we need to establish for business or services is the software. The software that manages the relationship between customer, the schedule of the passes, and or activities of maintenance and operation in general. I agree with Oliver. The other thing that we think is the most important innovation in the next years is the communication between satellites in orbit, in special if you have in mind in the next decade we have to operation in a lunar orbit. So this capacity to communicate in orbit in different Earth orbits and lunar orbit, it's very, very important, and this is the other aspect is the optical communication between because increase totally the bit rate, the data transfer rate between satellite and ground stations. I think that this for us these are the main innovative aspects that we are working and we are looking in the company.
Perfect, thank you. And Thinus, I would love to get your input as well on the same topic.
Yeah, absolutely. So from Pinkman's side, we come up from a bit of a different angle, that we focus on the processing of satellite imagery, and really specializing in the processing of many thousands of different satellites, hopefully soon, with all the new constellations being launched. And for us, the biggest challenge is the generalization, I would say, of the various different kinds of ground station as a service kind of partners that we have to work with, the different protocols that these satellites use, the different formats of their raw data, and bringing all of that from these various ground segments into a system in some unified form that is consistent and yet intuitive, to still get the maximum use out of that satellite data. So for us, the evolution on the ground segment side specifically, if we're talking about the antenna side of things, would be the normalization, I would say, of what that interface looks like to get your data into the broader cloud-based processing and data aggregation and dissemination system.
Perfect, amazing. So talking about that, right, generalization, as Thinus mentioned, so I would like to pick up on that point and move on to the next question with that, which is how can satellite companies collaborate with government entities to improve access to the ground systems and infrastructure, and how will this and what policies can be put in place to facilitate this collaboration, basically, to improve the access to the ground segment and infrastructure. And I think Juan was raising the hand, I think. Yes, you're currently on mute. Yeah, now it's fine.
Yes, I think that the most important aspect in that question is the regulations and fees for transmission and reception. For example, in Ecuador is an issue that we are solving with the government, but some years ago it was a problem, a really big problem. So first, the government has to work with the private sector to improve regulation and decrease the fees for different kind of uses. For example, we are proposing here in Ecuador separate the fees for space operation than fees for usual well-known satellite TV satellite already. The government has to recognize that there are different kind of uses in the telecommunication, in the space telecommunication right now, so need to develop a regulation that recognize that situation. Thank you.
Perfect. All right. So would anybody else like to comment on that as well? Okay, Thinus, go ahead. And
sure,
then
I can just mention from my side that our experience working with governments, specifically on ground segment side, often raises the topic of course, security, and but especially the ownership of both the infrastructure and software, and which is where it's most interesting for us. So the move to a ground station as a service model on the one hand, but also the processing infrastructure itself, how you and the move to the cloud, how you bring those two worlds together for a government organization, especially if it's a military organization that really wants to maintain the sovereignty over that system, and ultimately, of course, the data. And that is for us, it's an ongoing task to really to figure out where that balance lies between benefiting from all these cloud environments and distributed processing and all of these capabilities, and distributed receiving stations, yet give the government entity full control over not only their own data, but also the processing and so forth. And that is not a trivial problem, I don't think.
That's a fair point. So Srinath, go
Just
ahead,
to
please.
add on, yeah, sorry, just to add on what both Ivan and Tinas said, it's very important that government plays a very important role in policy and process and regulation, and most importantly, transparency. So if you look into the regulatory process, although it falls under ITU, every country has its own regulatory process, and you have to coordinate between countries to establish ground segments and also establish the frequencies, and then there is coordination. And the time taken to achieve this is depending upon which territory or which continent or which government you're dealing with. So if there is a single framework process, and if there is clear set timelines on achieving this, then it will help the private sector to follow the process. And the standardization is very important because currently the paperwork varies from one country to other. So if there can be a standardization on the regulation, then that's really good. And as Kylab said, we are getting into optical comms as well. So currently it's not something that falls under the regulatory spectrum of RF. So how the standardization is there and how that's going to be regulated, and easy interoperability is very important. So whatever technology that comes in, if it's easily interoperable and the process is simple and transparent, then it benefits the entire ecosystem.
Perfect. Perfect. All right. So that's that. This question is clear. I think Olivier wanted to add something.
I just wanted to complete what Shane mentioned about the
Sure.
optical comms. It's true that today optical comms is not regulated the same way as RF is, which is a very good thing on one hand, because it removes some of the constraints of regulation that can apply to this, but is also can be a risk since we need to see how this evolves and how this will be tackled by governments. We are seeing a lot of investment and policies being pushed by both US and Europe on constellations, SmallSats, including optics more and more. So clearly we need to monitor closely how this will evolve in the coming years. And we believe that governments will have a very strong part playing in this. Right now, optics is mostly regulated by aeronautics regulations, like don't blind the pilots with your lasers, you blind people, but it's a pretty different area of regulation that needs to be kind of become a common framework with the aerospace communications regulations.
Interesting to know.
Yes. Okay. So now moving on to the next question, which is a very big, again, issue, and it's one of the kind of foundations of the satellite operators and the ground stations, which is cybersecurity, right? So especially now what we have been seeing with this space warfare themes and all this political turmoil going on around. So how do the ground station operators actually make sure that their communications are safe and cybersecurity is top notch? Because that's, again, very important. And another follow-up question on that is, how important is that when dealing with the big corporations or the governments? So what is that level of cybersecurity that they're requiring for the partners and the companies to have when dealing with the private commercial companies? So Olivier, we can start with you.
I propose to start because Caleb is not at the operator level, but more on the plumbing. We propose the pipes through which the data moves, and we need to have these pipes. The first thing is to have these pipes as secure as possible, and then at the operator level and the software level, you can add some extra layers of security. But first, what we need to provide is a secure way to move information from one point to another, and optics really enters this by providing a very narrow beam that is very difficult to intercept or to jam. To give you an example, the spot size of a LEO to ground laser is 12 meters. So you need to have an extremely precise idea of where to search for information, which is already a very high level of security. Second, the optical ground station optical chain needs to be completely transparent to what's inside. It can be audited by governments or by private sector to make sure that all the photons, all the information goes through the pipes without interception or without being without any chance of being read by someone else. And finally, after the optical comms, optical communication infrastructure is in place, we can add quantum security on top of it. This is much more the future, but optics alone without quantum is already extremely secure.
That's a lot of security. That's good. Okay, so I think Srinath wanted to add on that as well, if I'm not mistaken.
Yes, as we know, as technology increases, the security also increases. So with optics, as we heard from Kylabs, that the security is really good. But with respect to RF communications, there are many software patches that you can include. And there are a lot of companies like SmallSat that are coming on both on board as well as ground software patches. And again, the cybersecurity is also depends upon what level of cybersecurity compliance you follow. With more and more satellites up in the sky, I think all ground station providers are quite keen on maintaining the security. And the other level of security comes from moving into the cloud. So you move into AWS cloud or Microsoft cloud, there is already data stored and it comes with its own level of security. So although we talk about cybersecurity and other things, I think the people who are taking care of ground segment is very much aware of the threats and already putting in process and procedures to mitigate these threats. And ground segment is catching up. As I said, you can have software patches, and there is also been development on getting onboard processors and encryption, decryption between the ground segment and the onboard satellite. So it depends upon what level of security you need, because again, the purpose of the constellation is very important. Is it a civilian mission? Is it a commercial mission? What is the level of security you need? And everything comes with a cost. So you have to decide what is the right mix to take forward in selecting your ground segment, as well as selecting the level of cybersecurity you want to protect your satellites with and data with.
Perfect. That's exactly to the point of the second follow-up question that I had, which is the how much more strict are the governments or let's say military structures in terms of the cybersecurity requirements that they have when dealing with the companies, right? So that would be a huge difference, as I understood from what Srinath said, right?
Yeah, absolutely. The difference between a military mission and a commercial mission is completely different. And again, when we go into the military side of things, then you're discussing about where the data lands, where the data protection lands, and what are the data protection rules particular to that government, to that country. And there are a lot of layers. And it's like all onion, you can keep on peeling the layers and understanding it in depth. So the understanding of the requirements is quite heavy on the military side rather than on the commercial side.
Perfect, amazing. So then would Tinos or Juan like to add on to that, or do we move on to the next question? How would you like it? So Tinos.
I can just from my side, it was very interesting, Olivier, hearing your perspective from about having the pipe secured, and we're talking about the interception of laser communication. That's something that my world does not include, of course. But just to echo the kind of the sentiment is of when data's in transfer over the internet, again, you know, on our side of things or on the networks, once downlinked, same likewise as was mentioned before, the keeping that data secure in transit and making use of the likes of AWS or Azure or their security services. Of course, we also have to keep in mind when data is at rest, it's not just when data is in transit. These data, once downloaded, whether encrypted or not, after it's been processed, it also needs to be secure. And there often, as also has been mentioned before, local government regulations often come into play, how that data is stored and what kind of databases and so on. And keeping track, from our perspective, keeping track of these requirements across the globe is also not trivial, because it differs so much between different organizations.
Perfect. So my next question would be, as the number of the satellite operators is increasing, and obviously the bandwidth is getting overloaded, right? And all these processes that are occurring. So what are some of the issues that you see that could be emerging due to that fact? And how would that be mitigated by a collective effort of the industry? And maybe we can start with Juan on that one.
Okay. Well, we see usual problems with grounded use of radio frequencies, technical problems about the overlap of signals, etc., etc. But I think that in our case, we done a different analysis. We are working to increase the participation of the emerging countries in the space operations as satellite operators, as ground services providers. So in this case, we are promoting the participation of the new actors. So definitely this action is going to increase the problematic of the use of the radio frequencies. And yes, we think that we need clear rules, international rules to organize the use of radio frequencies, but giving the opportunity to all actors to use these resources.
Absolutely, and that's quite a thin line, right? So it's always gets complicated. It's similar to the space debris issue, right? So you cannot just prohibit companies from putting out like those new constellations out there, but you also don't want them putting those out to that degree, right? So that's a similar analogical problem as I see. So the next question that I have is the interoperability. So how do the companies and startups, especially satellite operators or the ground station operators, make sure that their services are interoperable with those of other companies, right? So which is one of the, again, important issues. So who would like to take this?
I can.
Sure, both of you is fine. So,
So
maybe
you
let's
go ahead and
start
then I'll
with
catch up.
then with Dennis. Yeah, sure.
So interoperability is very important in ground segment, and I think most of the ground segment providers like KSAT, SSC, Telespazio are quite keen, and that's why we have developed a lot of APIs so that you can connect onto a common source, and ground station as a service has become of a common notion. So we have a lot of new space companies like LeapSpace and other Contech that are trying to disturb the market, but again, established providers like KSAT, SSC, and Telespazio also understand the need for interoperability, and then we provide easy APIs so that you can integrate and then choose the ground station process wherever you want. In Telespazio, with EaseRise, we have a service called Ground Station as a Service where you can connect multiple ground stations, pick and choose the process whenever you want, thereby reducing your cost as well as your access to ground stations, easy access to ground stations.
Perfect. So, Thinnus, now again, you wanted to comment?
Yes, I apologize for that. So, yeah, from our side, also the standardization, at least to whatever extent it's possible, of those communication protocols on the downlink, and here I'm again referring to the data stream itself. So whether it's based off of CCSDS spec or whatever the norm should be, I think there's still a lot to be engaged with there, so that the industry can come to some closer form of agreement there. And then, of course, on the outset side, the standardization of product format. And I realize this is a very elusive topic in the sense that it's been proposed for many years by many large organizations, large and small, and will probably never be fully attained. But I do think there's been already a lot of progress with regards to the discussion of how data is presented for the use of, say, data cubes and so on in a standardized enough format. And I think standardization in this kind in both these senses is got to be key for this expansion of and democratization of access. Yes.
Perfect. So Olivier would like to add. Sure.
Interoperability is a key question for optical communications, which is an emerging market, an emerging solution with evolving standards. So CCSDS is proposing some first version of the standard. On the other hand, the SDA in the US has proposed slightly different requirements in their RFIs. And they are putting so much money and moving so fast that it's becoming a de facto standard. So it becomes indispensable for optical ground station manufacturers to be both CCSDS and SDA compatible. And there's a critical point of getting laser comm terminals flying to ensure to have real tests. This is going to be the main challenge for 2023 and the coming years, is solving the chicken and egg issue by flying some chickens and establishing some ground station eggs on the ground and making sure that we can test them like cross test different with respect to different manufacturers and standards. On top of that, all the ground stations needs to be compatible with the existing RF ground station networks, because our optics will be complementary to this. There will be there'll be routing and site management issues that we need to, as a hardware manufacturer, we need to ensure it's compatible with all ground station operators, so that they can seamlessly integrate this into their network. And that's a big challenge for us and for other optical ground station manufacturers.
Perfect. Wonderful. All right. So the next question I have is, it's a bit interesting now as we're seeing a big spike, and again, that being the most searched topic in the search engines, which is artificial intelligence, right? So artificial intelligence and machine learning, two very huge potential that those two, again, emerging technologies have. So what would be the application of machine learning and artificial intelligence when it comes to the, satellite infrastructure and ground systems and linking those two with each other? So what would be the application and what would be the potential benefit of this application of those technologies? So whoever would like to take that, guess it's a bit different type of question character. So yeah, Juan, please go ahead.
Well, I short answer. I think that security and efficiency of the use of the radio frequency is, I think that is the most important benefits of the use of the artificial intelligence. Security, because is going to help to improve the encryption and security scams, and the same in the case of the efficiency of the use of radio frequency.
Wonderful. So Srinath wanted to also comment on that.
Yeah, we are touching the hot topic, right? And we can keep on discussing on it. But to give my thoughts on it, like artificial intelligence, machine learning, we saw the Planet presentation. So I think we have already started doing it. So most of the operations are automated. Most of the collisions are trying to be automated. And most of the gateway passes, scheduling, planning, accessing data, it's automated. So you can see slowly machine learning and artificial intelligence already being used in the system. And going forward, I think Tinus will agree with me that data processing. So if you're processing data from L0 to L1, L3, based on your past experience and with machine learning and artificial intelligence, I think most of the data processing can be done on board up in the sky, which I think currently it's quite costly, but with technology evolution, it will be cheaper. Also currently on the ground, these things are already being done and practiced, where machine learning and artificial intelligence is used in processing Earth observation data, particularly to get the image from L0 to L2, L3 or L4, and then correct the images and make more accurate predictions on the images. So I think it's already in play and it's going to develop further.
Yeah, and Tinus, again, I see he's nodding, so he approves Srinath, as you said. So perfect. So maybe Olivier would like to add to that as well.
I have nothing to add. We really, I don't think we are the right persons to use AI. We use very little software in our hardware development. So I fully agree with all the comments, all the previous comments.
Perfect. I see. Yeah, so basically we need to mix the artificial intelligence industry with the space industry. Yeah, so that's a good point, Olivier, by the way. We need to bring in the real experts in that subject, so like outsource. So that's very important. Okay,
just to add, just to add, but
Sure.
how much ever artificial intelligence or machine learning is there, you can't remove the human element from it. So there will be a bit of human element with space operations, and human prediction and human operations can never be overcome with artificial intelligence and machine learning. Maybe it takes another 30, 40 years, but currently there is definitely manual intervention, and you need people to look into the satellites and take anomaly chances.
Mm-hmm. Absolutely. And I don't think that's going to change anytime soon, as you said, in terms of the artificial intelligence without the human input. It's not really going to give itself a command. So that's yeah. So Thinus is raising the hand, I see. So he has some comment probably.
Yeah, I actually just want to kind of echo that sentiment. There's another aspect to this that we're seeing on the consumption of data side of things, and that is that especially if you're working with scientific quality data, the scientists want to know exactly what happened to that data up until that point, and they need to understand the physics behind whatever modifications was made to that data from a raw photon state as that photon hit the detector. And sometimes, depending, of course, on the application, AI black boxes might interfere with that process. So really understanding where it is that you use AI is also important. If it is for example, automated cloud detection and in onboard processing, yeah, sure, absolutely, if that optimizes your downlink. But if it is for the purpose of generating, say, data to be used for scientific analysis, then one has to be a little bit more careful. There's also a final comment. There's also a completely different side of things that I'm thinking of, and that is how, for example, the game theoretic approaches, for example, was brought in to optimize spectrum utilization in the cell phone industry, for example, and it's that same sort of area where AI might play a big role in optimizing the hardware required. The hardware assets that we have that have vastly different capabilities around the world to actually get to downlink the data from these thousands of satellites as they come online.
Perfect. Wonderful. All right. So we again covered now the artificial intelligence. We covered the cybersecurity. We covered the machine learning, right, a bit. But the next point here is moving into more of the international regulations and standards, right? We talked a bit about the standardization of things, but how do we really make sure? So do you believe that should be led by the government bodies, the standardization and setting those regulations on spectrum restrictions, or do you believe that should be a discussion between the industry players and the government? So that's a question.
I think it's definitely a discussion between all the parties involved, the government, the providers, as well as the customer, because not one person can dictate the term. So I think a dialogue should go back and forth, and there must be a feedback loop which achieves the maximum efficient possible way of using whether the spectrum or the optical solution. So I think everyone involved in the process must have a fair say in it, and the best solution should be down selected with the proper discussion analysis and should be backed by data. So I don't think one person can decide on it.
Absolutely agree with that point. So I think nobody will disagree. So Olivier, go ahead.
Of course, nobody will disagree. And I would add to that it's important to add everybody in the table, including new space and startups and small companies who might bring innovative solutions that are not taken into account in, let's say, legacy regulations that are based on 20, 30, 40 years of technology. So there's so many new technologies. You mentioned AI, machine learning. We can mention optical comms with a lot of innovative ways to deal with turbulence, with a lot of different challenges. And all this, if you look at them only from the legacy standpoint, you might end up defining standards that are already obsolete and that would definitely ban new technologies to emerge. So it's really important to bring everybody around the table and have this feedback loop that Shreen mentioned. It's really important and have evolutive standards.
Perfect. Absolutely. Yeah, that's a key takeaway, obviously, that involving all the parties when making the decisions and the policies and standardization. So that's very important. Okay, so we covered a lot of different aspects here today. It was very insightful. And we can sum up with the last question, obviously, which will be, okay, we talked about the artificial intelligence applications. We talked about the cybersecurity and those new other emerging technologies that can be leveraged. But what is next? What is beyond that? So where else is the room for innovation that can again be used for new services and applications in the space industry? So I would love to get everybody's input on that. Maybe in 2-3 sentences, we can summarize each one of you. So we can start with Shrinath, maybe.
Yeah, perfect. So as we saw, we have been innovating and innovation never stops. So initially we were looking at RF rings, then you had the S-band, X-band. Now we are talking about K-band, and then we are talking about other bands as well. On the RF side, we have the optical communications that's been developed. We're talking about inter-satellite links, and then we are talking about ground to say. So I think you can't just say that the innovation is going to stop at one point. It keeps on innovating, and the purpose is to be much better than the previous version of it. So if you think about the industry, it's going in the right direction, and with a lot of new space companies and startups stepping in the recent decade, I think the innovation has taken a leap, and this leap is going to multiply many folds. It's like the data evolution. So initially we had floppy disks, then we had CDs, and then now the data has exploded. Similarly, the space is going to explode. So currently we are looking at Earth's observation, then we will go into Moon, Mars, and maybe the next universe. So you can't put a limit to innovation.
Yeah. Absolutely. So Juan, maybe you would like to comment as well.
Not much to add, but I think that we could say that the most innovative aspect is the way that we see the business of the ground station. We need to change the way that the users, customers access to our services. It must more easy to access our services. This increase the amount of data, the flows of data, and users applying this information, this data to uses on the earth, in the agriculture, in the government planification. We consider that kind of innovation in the way that we understand the business, it's crucial. For example, for emerging countries like Ecuador or other countries around the world.
Mm-hmm. Perfect. So, Thinis, your comment as well. I would love to get that.
I would like to start by echoing Juan. It's actually something that's very dear to us. The idea that to have access to data that is simplified to the extent necessary without losing, of course, any quality. So still having access to the best that's possibly out there, especially when it comes to, like I mentioned before, scientific data. It should be intuitive. It should be easier. As we're getting emerging markets from where I'm from, for example, in South Africa, in Africa, online, having these people bringing them into the fold needs to be more intuitive. There's a lot of room for improvement to give them access to these new technologies. New space makes it easier to get hardware in space, and we're seeing these programs trickling down to the emerging markets, but there's still a lot of room for improvement on that front. And I think automation, as we've mentioned before, moving to decentralized processing environments, the cloud, if I can use that overused term a bit, but still with a focus on having that quality of data, that quality of servers that we used to from these legacy space providers, if we're thinking about, say, the Landsats and the Copernicus programs and those kind of missions, that we maintain that level of reliability, yet make it that much easier to access. Yeah, absolutely.
Absolutely. And Olivier, please, your final remarks as well and we can conclude the panel with this.
So I'll echo what Dennis said about the quality of data, which is really important to maintain, but also quantity, not just quality. And the quantity is exploding. And we strongly believe that we are on the verge of a revolution brought by optics. And this will revolutionize the ground station level, but it's also satellites, which in a few years will all EO satellites will need to bring on board some optics to ensure fast downlink. So we really feel that there's going to be a strong need for innovation in the next 5 to 10 years. We are bringing something, optics, which will be 50,000 times faster. The promise is 55,000 times faster. So what do you do with this? What new use cases you open? How do you ensure that your data is securely transferred? This is all open questions that we're starting to answer, but it's just the beginning. So we are really think that this will open new fields of innovation that are not explored yet.
Absolutely. So very exciting decade ahead of us. So that's going to shed a lot of light on what's going to be the latest developments and where we're going to see the most of the breakthroughs. So thank you once again. So Olivier, Dennis, Juan, and Srinath for the insights that you provided. I believe this was a really valuable panel for the attendees, obviously, that whether that attending live or that are watching this recording right now, I'm sure they learned a lot and they got a lot of insights into the satellites and the ground station linking between each other. So that's very, very important. So thank you once again. And with this, I would like to conclude this panel. So once again, thanks to the attendees. We had a very long day today, so 12 hours day. So we had a lot of keynotes. We had 4 panels, which was just as insightful as this one. So this just the beginning. It's just the first day of the conference. And whether, again, you're attending live or you're watching this recording, you're going to find the links, which will allow you to go to the speaker page, where you can directly reach out to the panelists that we have here currently. You can request a networking session with them if you're looking to, again, do business with them or reach out for other collaboration or just for the networking purposes. So please make sure to do so.